Let's explore covalent bonds. Not all covalent bonds are the same. They can be divided into two main categories: polar and nonpolar. Polar covalent bonds occur between two or more different nonmetals with different electronegativities. For example, H2O, HCl, PCl3. Nonpolar covalent bonds occur between identical nonmetal atoms. In these molecules, electrons are shared equally because the atoms involved have the same electronegativity. For example, H2, N2, S8, and P4. Now let's learn how covalent bonds are created. And let's start with covalent polar bonds. To write covalent bond formation, you want to write each element separately and mark their valence electrons. So we have two hydrogen with 1 electron each and oxygen with 6 valence electrons. These electrons are called lone pairs, and they do not participate in covalent bond formation. We're only interested in unpaired electrons. Each hydrogen has 1 unpaired electron. Let's mark them green, and oxygen has 2 of them. So what happens is that the electrons from hydrogen pairs with the electrons from oxygen, and they form a bonding pair. In covalent bonds, electrons are shared between the atoms. This structure is called the Lewis dot structure. Now let's look at the electronegativity of each atom. You can find various tables on the internet for this purpose. Hydrogen is 2.1 and oxygen is 3.5. Electronegativity shows how much an atom wants to attract electrons to itself. So in this case, electron density, or in simple terms, bonding pair, will be closer to the oxygen rather than hydrogen. And because of that, we have partial charges. The electron-rich atom is marked with a delta minus sign, and the electron-poor atom is marked with delta positive charge. Lastly, from the Lewis dot formula, we can write the structural formula. What you need to remember is that one bonding pair is a single bond, two pairs, double bond, and three pairs, triple bond. So in this case, between the hydrogen and oxygen on both sides, we have one bonding pair. So we will have two single bonds between the atoms. Let's look at phosphorus-free chloride covalent bond formation. Phosphorus is in a 50 group, so it has 5 valence electrons, and we have 3 chlorines with 7 valence electrons in its outer shell. Each chlorine has 3 lone pairs, so we just ignore them, and 1 unpaired electron. Phosphorus has 1 lone pair and 3 unpaired electrons. So like the last time, unpaired electrons make a bonding pair between the atoms, and Lewis dot structure should look like this. 3 chlorine atoms are connected to the phosphorus atom, each having 1 bonding pair. To draw structural formula, we exchange bonding pairs for bonds. In this case, phosphorus and chlorine atoms are connected by 3 single bonds. Lastly, chlorine has a higher electronegativity than phosphorus. So each chlorine will have delta minus sign, and phosphorus delta plus sign. Let's look at more complicated example of CO2. Carbon is in the 4th A group, so it has 4 valence electrons. Each oxygen has 6 electrons in its outer shell. Each unpaired electron pairs. In this case, each oxygen has 2 of these electrons, and carbon has 4. So we'll have 4 bonding pairs because we have 8 unpaired electrons in total. So between the oxygen and carbon, we'll have 2 bonding pairs on each side. Like always, lone pair electrons don't interact with the formation of covalent bonds. To write the structural formula, we exchange bonding pairs for bonds. On each side, we have 2 pairs, so we get double bonds between the oxygen and carbon atoms. Oxygen electronegativity is higher than carbon's. So it will get a delta minus sign and carbon delta plus. When we are talking about covalent nonpolar bond formation, it is essentially the same. In case of oxygen molecule, each oxygen has 6 valence electrons, and 2 of them are unpaired. So like always, we pair them and get 2 bonding pairs. Lone pairs don't interact with the formation of covalent bonds. Our structural formula will have a double bond between the oxygen atoms. The next example is the nitrogen molecule. Each atom has 5 electrons. 3 of them are unpaired, so we get 3 bonding pairs. And 3 pairs are equal to the triple bond. That's the basic theory of how polar and nonpolar covalent bonds form and how they differ. If you like to learn more about bond strength and how atom size affects covalent bonds, be sure to check out this video.